All right, here we're going to look at some pretty basic probability concepts. Remember that a probability is just saying the number of ways something can occur out of the total possible outcomes. So in this kind of set of rules that we're starting off with, there's a couple different pieces. So first of all, we're saying the probability of anything occurring has to be between 0 and 1. Right? 0 means there's a 0% chance, 1 means there's a 100% chance. You can't have a greater than 100% chance of anything happening, right? And you can't have less than 0. You can't say there's a negative 15% chance of something happening. We talked about sample spaces before, so if S is the sample space in a probability model, then the probability that we land in the sample space is 1. If it's not 1, that means there's some outcome we did not account for in our sample space. We've got to go back and adjust that. The complement rule is just saying if this is an either or. So you have some event A, it either happens or does not happen. So A happens, A does not happen is called the complement, A with the C up here in the exponent. So this formula is basically saying, well, if you know the probability of A, you can do 1 minus that to figure out what the probability of the opposite of A happening is, or A complement. And then we have a couple of addition rules basically to figure out the probability of A or B occurring. So there's a simple one if we have disjoint events. Disjoint basically just meaning that A and B can't happen at the same time. So if you want to know what's the probability A or B happens, you can just add their probabilities together. Now, in Rule 5 here, we see that there's an added component. Well, if A and B, if it's possible that those things both occur, so that would be something like you have some dice, you're rolling them, maybe you're looking at the sum of those dice, and you want to say, well, what's the probability that the sum is 6 or even? And you go, okay, well, 6 is an even. So there's clearly some overlap there. So this would be a situation you would want to maybe consider the second rule here where we have to account for potential double counting in the probability of A and probability of B. So our first example, suppose you toss 2 4-sided dice. What's the probability of rolling a sum of 4 or less? So the probability of 4 or less, well, there's a couple ways to think about this. One way to think about it is to say, well, any sum that I roll is sort of disjoint from the other sums. All right, so I could roll a 4. Well, and let me actually put in an intermediate step here. So we can think about 4 or less as 4, or we roll a 3, or we roll a 2. And we looked at an example before. 2 is actually the smallest sum we can have. That means both of our dice showed a 1s, right? 1 plus 1 is going to be 2, so that's the smallest one. So because 4 and 3 and 2, those sums are all disjoint, then we can say, well, I'm going to use Rule 4 here that just says, let me add up their separate probabilities. And if we're thinking to ourselves, okay, well, 2, the only way to get that is to roll a 1 and a 1, no problem. 3, the only ways to get that would be a 1 and a 2 or a 2 and a 1. Remember that these 2 dice are distinct dice, so even if they're the same color or they're identical, you roll them, we need to account for the fact that those dice are still separate. You know, a 1 and a 2 is still different from a 2 and a 1. And the best way to think about them is treat them as different colored dice so that you kind of have that in your mind. Rolling a 4 can happen in 3 different ways. We can do a 1 and a 3, 2 and a 2, or a 3 and a 1. And again, we see 1 and 3, 3 and 1. Those are different things. So when we're going for probabilities, we need to know, well, okay, 3 possible outcomes out of how many? 2 possible outcomes out of how many? So we can say this on the top, right, the number of outcomes for our event versus number of, well, I should say number of outcomes desired. Right, we want to get a sum of 4, 3, or 2, and number of total outcomes. This would be the size of the sample space. Well, we just said there were 3 plus 2 plus 1. There are 6 possible desirable outcomes. And then as far as total outcomes for the sample space, we actually did this in a previous problem. We said, okay, if the first die has 4 sides and the second die has 4 sides, then we can do 4 times 4. It's a multi-stage situation. There should be 16 total outcomes. So 6 out of 16 is our probability for rolling a sum of 4 or less. Okay, in the second example here, we have exactly 3 outcomes, which is A, B, and C. So kind of generically naming these. And they're going to be distinct outcomes here. So the probability of A is 0.23, probability of B is 0.51. So then we want to figure out, hey, what's the probability of C? Well, remember that the probability of our sample space has to be 1. All events in the sample space need to be accounted for. Well, A, B, and C, I guess that just means our probabilities need to add to 1, since these are the only possible outcomes. So probability of A plus probability of B plus probability of C should be 1. Well, we know 2 of these values, 0.23 and 0.51. And so we say, okay, let's just solve for the missing piece here. And there's a couple ways to do this, right? We could subtract 0.23 and subtract 0.51. We could also add these together and then subtract. You can work through this, again, any number of ways, but we would solve this thing and figure out that the probability of C, my typical way of going about this would be to add these first and then subtract them from 1. So together this is 0.74. We're going to subtract it from 1 and we get 0.26. This makes sense because it's between 0 and 1. And we could always double check. We can say, okay, 0.26 plus 0.51 plus 0.23. Does that get me back to a total of 1 like we wanted? And sure enough, it should. And then our next part here, what's the probability event B does not occur? So this sounds a lot like B complement. So the complement of B, the opposite of B. So if we want to find the complement or the complementary probability, we just say, okay, well, let me do 1 minus the probability that it does occur. So we know the probability of B is 0.51. So we're just going to do 1 minus that, and we should get 0.49. So basically, there's a 51% chance that B does occur. There's a 49% chance that it does not occur. And I'm kind of toggling between decimals and percentages just so that we can think about this a little bit more. Oftentimes we think better in percentages in the real world. So just kind of toggling between those.